Alright, this is Unit 2, this is Algebra 2. We are talking about relations and functions. Okay, relations are just, they're just relationships between numbers, and I found a very good example to work with one. Okay, and this is functions versus relations in Purple Math. I'm reading it through Readability. It's a really great little thing because it takes out all the extra stuff. A relation is just a relationship between sets of information. Think of all the people in one of your classes and think of their heights. The pairing of names and the heights is a relation. In relations and functions, the pairs of names and heights are ordered, which means that one comes first and the other one comes second. To put it another way, we could set up this pairing so that either you give me a name and then I give you a person's height, or else you give me a height and I give you the names of all the people who are that tall. The set of all the starting points is called the domain, and the set of all ending points is called the range. The domain is what you start with, the range is what you end up with. The domain is the x's, the range is the y's. Okay. A function is a well-behaved relation. Just as with members of your own family, some of the members of the family pairing relationships are better behaved than others. Okay, warning, this means that while all functions are relations, since they pair information, not all relations are functions. Functions are subclassifications of relations. When we say a function is a well-behaved relation, we mean that given a starting point, we know exactly where to go to. Given an x, we only get exactly one y. Okay, and if we return to your classmates and their heights, and let's suppose the domain is a set of everyone's heights. Okay, and let's suppose there's a delivery guy waiting out in the hallway, and the delivery guy knows that the pizza is for a student in your class who's 5'5". Now let the guy in. Who does he go to? What if no one is 5'5"? What if there are 6 people in the room that are 5'5"? Do they all have to pay? What if you are 5'5"? And what if you're out of cash and allergic to anchovies? Are you still on the hook? Ah, what a mess. Okay, the relation height indicates name is not well behaved. It is not a function. Given the relationship x comma y, 5'5" person, comma name, there might be 6 different possibilities for such a name. For any relation to be a function, there must be only one and exactly one y that corresponds to it. Here's some pictures. These are function maps, and they just show you how functions work. So for example, -3 is in the domain, and then you plug it in and you get out range of 3. Okay, you can tell this is a function because you can trace from each x to each y. Okay, and there's only one y for each x. There's only one arrow coming from each x. Okay, now from this one, you might be going, oh, that's not a function, but in fact, this is a function. You're going from one x to one y. They just happen to be all going to the same y, and that's okay. Now, if the reverse was happening, for example, we had another number here, and -2 went to both -6 and that other number, then we would have issues. Okay, and that's what this one's exactly saying. Okay, there are 2 arrows coming from number 1. The number 1 is associated with 2 different range elements, so this would not be a function even though there's no picture. Okay, now this one right here, you'd think this one is actually a function because it's going from 1 to each, but in fact 16 is not going anywhere. Okay, so this is not a function, nor is it a relation, so it's really interesting how it works. Okay, now you've heard of this, the vertical line test, everyone, so this should not come as a surprise. Okay, look at the function stuff graphically. What if we had a relation that consists of a set of just 2 points, 2, 3, and 2, -2? Okay? Alright, we already know this is not a function since x equals 2 goes to each of y equals 3 and -3. But if we look at it, they're both over each other, so this would not be a graph because it does not pass the vertical line test. Okay, for example, this parabola would pass the vertical line test because if I had a vertical line looking like this, it only touched one point. However, this graph of an ellipse would not pass, and it is not a traditional function because it does not pass. However, this is a relation, so this totally works. Okay. Alright, now, is it a function? Quick answer without the graph. Think of all the graphing you've done so far. The simplest method is solve for y equals make a t-chart, put some values for x, solve the corresponding, plot your points, and connect the dots, yada, yada, yada. Not only is this useful for graphing, but this methodology gives you another way of identifying functions. If you can solve for y, then it's a function. Okay? In other words, if you can't enter it into your graphing calculator, then it's a function. The calculator can only handle functions. For example, 2y plus 3x equals 6 is a function because you can solve for y, and you set it up. On the other hand, y squared plus 3x equals 6 is not a function because you cannot solve for unique y. For example, when you solve it, you minus the 3x and then you square root it. Now we have two positive and negative versions. It's not unique. We don't know which one it works with. So, you know, it's just something that you have to just go through and just take a look at. Now, what if we were looking at Desmos and we were trying to work with this? So, for example, let's take the absolute value from last unit. Let's see if it's a function. Okay, so what you do is you graph x equals a number. You can say any number you want. That's interesting. Y equals a. There we go. Okay, now let's change this to an x. Okay. All right, now, so if we change how this is, okay, as you can see, the vertical line test, we only touch the graph once, so that's good. Now, if we want to graph something really funky, let's go x equals, or nope, the square root of x. Okay, if we test it out with the vertical line test, then that works. But if we put also a negative version, so negative square root of x, and we pretended that these were both the same function, okay, you can see that it does not pass. And what I do is I set up my equation as x equals a, I set up my slider, and I just move it around, and I can see if it's a function or not. So it's a really good way of doing the vertical line test, okay? All right, so relations and functions. Just take your time. Remember, relations, if we think about this in terms of abilities, relations is huge, okay, but a subset of that, let's do this, a subset of that is going to be functions, and they're well behaved. So kind of like at family functions, you got the well-behaved family over here and then the crazy people out here. Okay, and there's a lot more crazy people than just regular well-behaved people. And in math, we have that definition set up for us. All right, thank you guys. Have a great day, and I'll see you later.